Hi, I'm Pat Hindle, editor at mmWave Journal, and I'm here at IMS 2016 with Aguago. He's with Rogers Corporation.
Thank you, Pat.
We've heard a lot of talk about 5G technologies. What's your view on that from a materials perspective, and where is that heading?
Sure. Well, 5G is really all over the news. 5G and what that means. In the sense of the promise of a whole worldwide network, and with everything is achievable. So what Rogers is trying to do is understand first separate the myth from the facts, right? We hear things about lower frequencies, 6 gigahertz, and then as high as 28, even 68 gigahertz in this arena. So first is we're trying to understand what really people are trying to do in lack of standards, which is expected not to happen until like 2018. So various companies are approaching it in different ways based on their knowledge, their frequency bands available in their regions of the world. So Rogers is having to kind of, from a position of a technology, being agnostic to technology, we really have to work with various folks, as we really won't know what is the right direction things will go, right? So we take information like what Verizon has said, that they're going to roll out some pre-5G activity in 2017. You have Korea in the Olympics, Korea Telecom, making a push for, hey, we want to have 5G for enhanced, experience for people attending the Olympics. So we have to take all this information and work with the various OEMs, and what does that mean at the material level, right? So in lack of a true standard, we have to evaluate higher frequencies, better characterization of the materials that we have, see what we can do to reduce losses in case things do go in those directions. It is not clear that really, for sure, we will be at 28 or 68, but if they do, we want to be prepared. So we are working with lower loss or smoother copper foils for lower insertion loss. So we're working with that. We believe the material sets that we have today will fit well at 40 gigahertz, 68 gigahertz, because they're using them today in other markets, right, like microwave radio backhaul, like automotive radar sensors. They're using them already. So we tell people, what is our material for 5G is the question that they ask us. What's your 5G material? And we go, well, it's what we have already today, we believe. But if things change, we have a very good R&D team to develop what be the new resin systems and the new material composites that we'll need if something is different. Right. So that's what we've been seeing, at least in the area of 5G and from a materials perspective.
And so another hot topic is IoT. So in your view, how does that fit in together, or are they separate technically?
Yeah, that's the other thing. You Google 5G and IoT, those things come up everywhere. And we think they're really linked, right? Today, IoT is more of a machine-to-machine, which we've had really for quite some time. Rogers has programs that we have sold into, like RFID automatic toll booth systems. Right. We've seen also things where some of these utility meters, wireless utility meters, we're selling some materials in those applications as well. So what we believe is going to happen with IoT is that as 5G really becomes ubiquitous everywhere, and then the kinds of applications like automotive is one of the big ones that we're seeing, is that the ultimate mobile device is the car, right? We see those things merging together. So 5G and IoT will eventually, be one word in essence. We won't be able to separate that. Everything will be a smart something, right? We all hear the smart, the smart home, the smart. You'll think like, oh, I guess that's where we're going. Everything's smart. But that, in essence, means more integration onto chips. And we are seeing some people wanting to use more higher performance materials, because you are putting a lot more value now on those chips. So we are seeing maybe a transition of things where maybe FR4 was used before, and they're trying to get squeeze a little bit more out. So we have some materials that we're going to be introducing a little bit later this year that will address that kind of like in-between part of the market where you're moving up in the performance to FR4, but you still have to be quite cost sensitive to that. So we're going to be addressing that in that respect. But yeah, I would say there's that merging definitely of IoT and 5G and what it will be 10 years from now.
And you are also a founding member of the RF Energy Alliance, which is a hot topic too. How is that going?
Yeah, that's indeed. So RF Energy Alliance, it was founded about 2 years ago. Rogers was one of the founding members of this organization. We're trying to promote, enable the adoption, create standards, help drive costs down of the use of solid state technology in applications that are different from communications where everything is really used today. RF cooking is the first major one right now that we're working on, and this is where we're trying to replace a magnetron with solid state approach, right? So replacing a 1,000 watt magnetron with better solution with amplifiers. So Rogers piece is providing the materials that can handle high power levels, that have very high reliability, that can handle the thermals at that temperatures. We believe that you don't need to have as high a wattage as a magnetron because these can be more efficient in transferring the energy to our food. But it's a challenge. This is still something that is quite more of a challenge than just producing a high power amplifier for communications, which are 80 watts, maybe getting now as high as 100 watts. These things that could be 250, 300 watt single amplifiers that then have to be cascaded to generate maybe 750, ultimately 1,000 watts, but we don't think it has to go that high. So Rogers has been doing that. We're getting more momentum in that, more interest, a lot of people coming by and asking us about that, visiting the other booths of the other members of the organization here at IMS. So we think we're kind of reaching that momentum, the critical mass, where it's really moving now forward. And we think it will open up another revenue of adoption for materials for high frequency. So we're quite excited about that.
Great. Well, Rogers has a wide variety of materials for a lot of different markets, and a lot of things are going higher in frequency, and you're always there, and you have the research teams to back it up around the world.
Correct.
So.
Well, thank you. Yeah, and I would say Rogers a couple years back created we saw that the future sometimes. You have to look way out there, and it takes time to develop these materials. So Rogers created what we call the Innovation Center, which is located in Burlington, Massachusetts. And this is a group of our scientists that really are looking at stuff that's 5-7 years out there. So sometimes it's hard for them to put into words what they're actually working on, because it's sort of like we don't know until we get there, exactly. Yeah, but we're coming up with some great ideas in those areas. We're exploring areas of magnetism. We're exploring areas of molded dielectrics. A whole bunch of different things. Because again, 5G and all this communication that's going to happen everywhere, and these other areas of RF Energy Alliance and high power and thermal management is opening up a lot of other avenues. So we look now at things that we're not really a materials supplier. We want to be part of a solution supplier. Hence, we renamed our organization Advanced Connectivity Solutions to really address that and finding a way that materials can help achieve the solutions for tomorrow's designs.
Great. Well, we really appreciate you taking the time to talk to us today at IMS 2016.
Well, thank you very much, Pat. Thank you.